All right, in this video, I want to talk about the domains of composed functions. Okay, in order to do that, let's start out with this. Suppose that f of x and g of x are functions, okay, with the following domains given here, script d subscript f and script d subscript g, respectively. Okay, we are concerned with the domain of f composed with g. Okay, all right. Now, let's recall that f composed with g of x is just what? F of g of x, okay? So I've drawn that there. That's just a matter of definition, right? Okay, now we know how to compose functions now. In order for f of g of x to exist, it's necessary and sufficient that, okay, we'll see that this is necessary and sufficient. Well, first of all, in order to compute something like this here, think about it. Well, g of x better exist first, right? Okay, if I'm dropping x into g first when I compute this, g of x better exist. So, okay, and then once I compute the value of g of x and drop that into f, that value better exist, which means that what? G of x better be an element of the domain of f, okay? Okay, now another way to say this, g of x exists, would be that x is an element of the domain of g, and here, and g of x is a domain of f, okay? So the domain of f composed with g is in fact the set of all x that satisfies this then. Okay, now a shorthand way of writing that, the domain of f composed with g is the set of all elements that are in what? The domain of g, whose what? Image, g of x, is in the domain of f. Okay? All right? So let's go ahead and take a concrete example of that. Okay? Suppose f of x is the square root function. Okay? Now, in these, by the way, notice that I haven't put any limitations on these. Okay? So we're just going to assume that they assume they're natural domains, they're implicit domains. Okay, now we're only sticking to real numbers though. Anyway, and g of x is x minus 3. Okay, what's the domain of g here? Okay, because I'm considering above. You can see this is all real numbers, right? So I wrote that with interval notation from minus infinity to infinity. Okay, yeah, I can stick any real number in that formula for g of x, and I'll have a real value coming out, right? Okay, what's the domain of f? Okay, the domain of f would be what? From 0 to infinity, including 0. Okay, so these are all the non-negative numbers. Remember, I can only take the square root of, I can take the square root of a real non-negative number. I can take the square root of a real number and get a real value if and only if that real number is greater than or equal to 0. Okay, so that's all I've said here. Okay? All right, now what would the domain of the composition f composed with g be then, according to what I have up there? It'd be the set of all x that's in the domain of g, right? The inner function there when I compose. We'll see that in a second here. That would just mean that x is a real number, right? X is an element from minus infinity to infinity. X is all real numbers such that, remember the vertical bar, x minus 3 is an element of, because that's g of x, right, is an element of this set from 0 to infinity, including 0 in there. Okay? All right? Now, we want to rewrite this. This is true, but it's not quite clear what the values of x are yet. Okay? Now let's go ahead and think about the second part. The first part's easy. X minus 3 is an element of this set from 0 to infinity if and only if, what? X minus 3 is greater than or equal to 0, right? Because this and this are saying exactly the same thing, right? Okay? And on the other hand, x minus 3 is greater than or equal to 0 if and only if x is greater than or equal to 3. That's just found by adding 3 on each side of that inequality, right? So what's the domain? Well, let's write it in more shorthand here. The domain of f composed with g would be the set of all x, right? So this is implicitly real, so I'm just writing that instead of that up there, okay? And then such that, what? X is greater than or equal to 3. As a set in interval notation, that would be what? From 3 to infinity, and you want a square bracket on 3 because we are including 3, okay, in our set here. Let's go ahead and check, okay? F composed with g, okay, that would be f of g of x, okay, so f is the outer function, so that's the square root, and the inner function would be x minus 3, okay? What would be the implicit domain of that, right? Okay, that would be everything from 3 to infinity, including 3, right? Okay, just give that a little look there. Those are the only values of x I could plug into that formula and have it make sense in the real numbers. Okay, let's try another one here. Suppose that f of x is the reciprocal function and g of x is, say, x squared minus 16. Okay, the domain of f would be what? The set of all values of x such that x is not equal to 0. Okay, notice I didn't use interval notation that time, right? You can anyway, you can take the reciprocal of any non-real or non-zero numbers, so we're cool with that. How about the domain of g of x? Well, once again, the domain here is all real numbers, okay? I decided to write this with set builder notation. The set of all x such that x is between minus infinity and infinity, okay? So that's another way of writing all real numbers, okay? Now let's do this then. The domain of f composed with g would be the set of all x such that what? X is an element of this set, right? The x is an element of the domain of g, so that means x is just a real number again, okay? And it has to satisfy that what? G of x, which is x squared minus 16, is not equal to 0 here, okay? So we're replacing our x by g of x there, you can see, okay? So x squared minus 16 is not equal to 0, right? Okay, remember we're doing that, right? Okay, so g of x has to be an element of the domain. That's equivalent to saying g of x, which is x squared minus 16, is non-zero. Okay, now let's just solve this in our heads real quickly. Again, the first part is just saying x is real. The second part, x squared minus 16 is not 0. Well, the easiest way to solve that is find out where x squared minus 16 is equal to 0. And that would be at what? Negative 4 and 4. And then what? Take those two values and kick them out of the real numbers. Everything that you have left is the domain, right? Okay, so here I've written that in interval notation. From minus infinity to minus 4, union minus 4 to 4, union 4 to infinity. Okay, so that would be the domain. Let's go ahead and check that here. Okay, the composition, f composed with g of x, would be 1 over x squared minus 16. And you can see that this thing indeed would exist everywhere except at 4 and negative 4, okay, which is what we have above. All right, let's take a different example here. Again, I'm still going to be considering f composed with g. Now, you remember when we're using arrow diagrams, or what we call maps, okay, when we write these, remember if you're going to do something like this, you're actually going f composed with g of x. Okay, so you're computing or finding g of x first. So in our arrow diagram, although we're writing f composed with g, g actually comes first, okay? So that's why I've written it on the left. We're sort of thinking left to right here. Okay, but here it is. G is defined this way, okay? So 1 points at 5, okay? So that would be saying g of 1 is equal to 5. 2 points at 11, so that's saying g of 2 is 11, and so forth, okay? We've got another function, f, over here. So this would be saying f of 5 is 7, f of 12 is 18, and so forth. Okay? All right, what would be the domain of g? Okay, the domain of g, well, that's pretty easy from our diagram here from a map, it would just be the set of all these values, okay, right there, 1, 2, 3, 4, from which arrows are emanating, right? Okay, so there's the domain. I'm going to look at this slightly differently this time also, okay? So I am going to consider also the range here, which is sometimes harder to find, but it's pretty easy in this case, huh? Arrow diagrams. 5, 11, 13, 23, that's the range of G. Okay? What's the domain of F? That would be what? These guys, 5, 12, 13, 23, and 27. Okay, so I've written that there. Now, the domain of F composed with G would be what? The set of all X that are in the domain of G and satisfy the condition that G of X is an element of the domain of F. Okay? Okay? Now, if you go through these one by one here, let's see, we could start with 1 here. Okay, 1 is obviously in the domain of G. Is its value under G, its image under G, which is 5, is that actually part of the domain of F? Yep. Okay, because you can see 5 is in there. Okay, so 1, we want to include 1. How about 2? Okay, G of 2 is 11. Is 11 part of the domain of F? No. Okay, how about 3? G of 3 is 13. Is 13 an element of the domain of F? Okay, is it part of the domain of F? It is. Okay, there it is. Okay, so we will include 3. Okay, 4 points at 23, sorry. 23 points at 41 over here. So indeed, 4 will also be included here. Okay, so that would be the domain of the composition. Okay, here's another way of viewing this. Okay, I'm writing this other way of viewing it because we know what the domain of the functions are, but we also know the range of G easily. Okay, the range of G is 5, 11, 13, 23, right? Okay, so these are the values that are coming out here. Okay, all right. And then I'm going to intersect that. Remember that symbol intersection? I'm going to intersect that with the domain of F, okay, and see what elements they have in common, okay? So I'm intersecting these two sets right here, okay? This would be a way of finding what? Of finding the image elements of G, or the range elements of G, that also lie within the domain of F, right? Okay? So this is supposed to be rounded off. That's intersection. Okay? Okay, if I intersect those two, do you see, remember intersection is just what common between the two sets? I would get 5, 13, and 23. Okay? 5, 13, and 23. And now, I'm talking about what this is saying is 5, 13, 23 here. Now, to find the domain of F composed of G, I'm just wondering which elements of G give rise to 5, 13, 23. And the answer is 1, 3, 4. Okay? So we could call those the pre-image under G elements here. Okay? We still get the same answer. 1, 3, and 4. Okay? All right? That's a different way of thinking about it. But I hope you understood this and are going through the problems in the homework. Okay? Alrighty?